Okay, so this is the last of the lessons that we have with radical expressions. Before we take a test on radical expressions, and in this lesson we are going to simplify some radical expressions, or actually rationalize the denominator. And this is something we've done before, but we haven't done it using what's called a conjugate or conjugates. Okay, so that's what's going to be new here, but other than that, it's basically the same stuff we've been doing. Conjugates are whenever you have two expressions that look the same, like root 5 plus root 2 and root 5 minus root 2. And you'll notice, though, that they are different. They look the same, but they are different because one has a plus sign and one has a minus sign. Okay? Now, when we multiply two conjugates together, it's very useful because the middle two terms that you normally get when you distribute, they cancel each other out, and that gets rid of radicals or square roots for us. Okay, so let's go ahead and look at this example here. If we were to multiply these two conjugates to see what I mean about those two radicals canceling each other out. So first off, we have root 5 times root 5. That's 5. And we have root 5 times negative root 2, which is negative root 10. And we'll draw these arrows. And you'll see that we have positive root 10 and negative 2. Okay, 5 and the negative 2, think about it. Root 25 is 5, so that's where that 5 came from. And negative root 4 is negative 2. Okay, so I skipped a little step there, but I think you guys are okay with handling that. We've done that a few other times. Alright, so now if you look at what we have 4 terms, but the middle two terms are opposites, so they cross out, and we're just left with 5 minus 2, no more radicals, which is what we wanted to have happen, and that's 3. Okay, so our goal in using conjugates is to get rid of radicals in the bottom of a fraction, otherwise known as rationalizing the denominator. One other thing I wanted to point out before we do some two problems here is that the quick way to think about this multiplication is, rather than distributing, since the two middle terms are going to cross out, we're just going to do the first two terms multiplied together, which gave us that 5, and the last two, which gave us the minus 2. Okay, it's always going to be a minus between the two numbers whenever we multiply conjugates. Alright, let's do two problems here. And I'm going to have to pause this because I forgot that I don't have the problems on my page here, so give me a second. Alright, so let's see. Here's our first problem. We're going to have 6 over the square root of 5 minus the square root of 2. And what our goal is to get rid of these radicals. Can't have them in the bottom of a fraction. So in order to do this, I am going to multiply by the number 1, but it's going to be the number 1 in disguise. And remember, I can multiply by 1. Alright, so anyways, I think I was saying that, oh yeah, nice and tired, that we're multiplying by 1, but it's going to be 1 in disguise, and you're allowed to multiply any expression in math by 1 because it doesn't change the value of the expression. Like 10 times 1 is 10, 500 million times 1 is still 500 million. Doesn't matter, you can multiply by 1 all day long. It doesn't change the value, so we can do it. Enough with me talking about it. Let's go ahead and do it. Here's how I'm going to do this. I'm going to take a root 5, this is key, plus, it's the opposite sign, it's minus down here, you use a plus, root 2. Okay, that is no good though unless we divide it by itself, which makes it worth 1, and that makes all of this mathematically legal. So I'm going to multiply by the conjugate over the conjugate. Okay, here's the step that nobody likes, but I would like to put it on here because you mess up if you don't do it. You take the 6 times the quantity. Yeah, it's a quantity because there's a plus sign or a minus sign. In this case, plus sign. Times the quantity, root 5 plus root 2. On the bottom, yeah, I said bottom. It's denominator, I know. Root 5 minus root 2 over root 5 plus root 2. Okay, we're set up. to figure out what's going on here. So let's go ahead and distribute the 6. So we have 6 root 5 plus 6 root 2 over, now here's where the magic happens. Let's use pink. Since these are conjugates, we're just going to multiply. We can use this shortcut. The first two terms together, root 5 times root 5 is 5. Negative root 2, positive root 2 is 2. And a negative times a positive is a negative. It's always going to be a negative when we do this. Alright, so let's continue writing what we have here. We have 6 root 5 plus 6 root 2 all over 3. And that looks nice, but I see that I can divide all 3 terms by 3. So I'm going to do that. I'm going to make this a 1, make those 2 6s 2's. So my actual final answer is 2 root 5 plus 2 root 2. Done. If you put it over 1, you could do that, but it's not necessary. So that's our answer right there. No more radicals in the denominator. In fact, our denominator is 1, so it's, in a way, it's there, but we don't even see it, so we don't have to worry about it. Alright, that is the first problem. Problem number 2, let's go ahead and do it. Problem number 2 is a little more complicated. Same idea though. So we're going to say that we have 4 over 2 root 2 plus 3 root 3. Alright, same idea. Have to get rid of those radicals, so we're going to multiply by, pay attention, 2 root 2 minus, changing the sign there, 3 root 3. That's what makes this numerator and this denominator conjugates, different signs. Alright. Remember, this is 1, so it has to be the same thing top and bottom. Okay? And let's set up the part that nobody likes. 4 times the quantity 2 root 2 minus 3 root 3. Okay? Down low, we're going to have these two quantities multiplied together, so we'll put them there. Alright, we're getting there. Uh-oh, I'm running out of room. Oh well, we see it. Alright, so let's write what we have here. Up top, we have 8 root 2 minus 12 root 3. That's when we distribute the 4. Down low, we have do this with purple. We have 2 root 2 and 2 root 2. That becomes 8. Alright, people are saying, what in the world? How'd you get 8? Let's do it down here. 2 root 2 times 2 root 2 equals 4 root 4, which equals 4 times 2. And 8 is what that is all worth. So that's where that 8 came from. Alright? Did a little math in our heads there. A little mental math. But that's where that came from. Then we have a minus sign. And we have 3 root 3 times 3 root 3. I need to get a tissue, don't I? And that becomes 27 or minus 27. Alright, where'd that come from? 3 root 3 times itself. I know one of them is negative. That's why there's a minus sign here. But 3 root 3 times 3 root 3 is 9 root 9. Which is 9 times 3. Where'd that 3 come from? Well, root 9 is 3. And 9 times 3 is 27. So that's where we're getting all that mess. Alright, let's finish our problem here. Up top, we can do nothing but look and rewrite. Can't simplify. Down low, you have negative 19. And I'm going to circle it because we're done. If you were being a good student of math, you would look at the 8, the negative 12, and the negative 19, and since you can't divide by anything other than 1 or negative 1, you just let well enough alone, and that's your answer. Okay? So remember that conjugates are whenever you have 2 terms, but one is positive and one is negative. Other than that, they look exactly the same. And we could use them to rationalize the denominators of fractions, meaning get rid of roots, radicals in the bottom of the fraction. Alright, that is the last lesson before test time.